Okay, guys, we're getting into Unit 2 today, beginning Unit 2. So today in Section 2.1, we're going to be discussing increasing, decreasing, and piecewise functions. So increasing, decreasing, and constant functions, this is actually discussing intervals. On an interval, a graph is said to be increasing if it rises left to right. So here's an example of an interval that is increasing, that little section. It is decreasing if it falls from left to right, so going down, that would be a decreasing interval right there. And then constant is horizontal, that would be if it stays the same, that would be that guy there. So in example 1, we are going to name the intervals on which the function is A, increasing, B, decreasing, or C, constant, and C, constant. So this has to do with the x values, so we're going to name them in interval notation, which you'll see in a second. Now, usually when I start off with these parts, I start off with the constant because it's the easiest to locate. So I go, okay, constant is this little flat portion right here. And I look and I go, what x values does that cover? That goes from -1 to 3. So I go -1 to 3. Notice I put squared brackets for on both of those numbers. That's because it includes -1 and 3. Okay, next up, I'll go into increasing. So this guy increases from left to right. 1 second. Right here. That interval increases. So that would be, I eye up the x values. That covers the x values from a -3 inclusive to 5 inclusive. Then the other two parts are actually decreasing. So I'll go, okay, I got a decreasing here. It drops, it falls from left to right. Now, the arrow here, the left value, the left x value, is actually going to be -infinity. Because of that arrow, it does go to the left forever, and then it goes up to -1. And then there's another decreasing value, so we put and then right here falls again, and that goes from 5 to the right infinity. So 5 to infinity. And actually, infinity should have parentheses, so I gotta go fix this one here. Not that the parentheses are important for infinity, the parentheses are actually most important for open circles. Okay, so let's scroll down. I want to show you a couple more examples. One is not enough here. So let's take a look. I'm actually going to bang out a couple of your homework problems, numbers 1 and 2. So we're going to do increasing. So that covers from here to here. Let me do highlighter. Here to here. So that covers from -5 to 1. -5 to 1. Then the next part is a constant. So right here is the constant part. So I'll put CON for constant, and that goes from 1 to 3 for the x's. And then the last little part is decreasing. So that'll be this, man, I'm all messed up tonight. That'll be decreasing here. So put DEC for decreasing, and that goes from 3 to 5 for the x's. It's a pretty easy concept here. Actually, I don't want to do 2 because 2 doesn't have open circles. I actually want to get to number 3. Number 3 has an open circle. So let's look for increasing first. So that would be this portion here. So that covers the interval that goes -3 to -1. -3 to -1. This is basically just counting, guys. It's really easy stuff. It is literally just counting on the x-axis. Then there's another increasing. That's why I don't understand why people skip the homework. Easy stuff, easy points. So there's another increasing, so I'll put and. That goes from 3 to 5. So another increasing interval from 3 to 5. All right, I do have a constant in the beginning, so constant, that flat part horizontal right here. Now that guy has an open circle, so close circle at -5, so bracket -5, but then close circle at -3. So the -3 does not get a bracket, it gets a parentheses. Means it is not included. And then we have one small part left. We have a decreasing right here. So decreasing, and that's going from 1 to 3. Okay, so now you know how to determine what intervals are: increasing, decreasing, and constant. Let's go back up, back to the beginning of the section. The next part is another part. It sounds intimidating. It's very wordy, but it's a very easy concept. It's called a relative maximum and minimum values. Think of like maximum values that are like peaks or the top of the mountain. Those are called relative maximum. So here, or if there's more than one, that would be maxima for plural. So for a maximum here, that would be right here, this top of this peak here. So what you would just do is you would say the maximum is, it goes as high as 5. Okay, the y coordinate is 5. Think of it as like 5 feet high or something. All right, maximum is how high, minimum is how low. So it has to do with the y values. So it's the maximum, and we say when it occurs. We would say it hits a maximum of 5 when the x is, and that would be right here, that would be when the x is 1. Okay, so the maximum is, say, 5 feet high, and it occurs when x is 1. That usually, like when we say x's, it usually has to do with time or distance. So the minimum is the opposite. We kind of refer to it as a valley. So here we do have a relative minimum. And if we zoom in, it's right here, this valley. So we go, okay, what is that point? How many feet is it? If we view the y-axis, that's right here. Well, that's 1. So the minimum is 1, and that occurs when x is, and we look at that's at when x is 3. Okay, so real easy stuff there. Notice one thing though, relative maximum and minimum does not have to do with the arrows. It does not have to do with the infinities. It just has to do with kind of curvature going on, peaks and valleys. Okay, next up, functions defined as piecewise. You guys did this in Algebra 2. So sometimes functions are defined as piecewise using different output formulas for different parts of the domain. An example of what like if I were to graph this guy here, this f of x with 3 parts, it could look similar to something like one of these guys. These are actually piecewise functions. Okay, they are in pieces. Here's some other, let me show you some other examples. Right here, these 6 guys. These guys are called piecewise functions. Let's find out where I left off right here. So functions defined as piecewise. Sometimes functions are defined piecewise using different output formulas for different parts of the domain. Again, this is going to seem like a foreign language here. Let me just break it down for you. So you got 3 parts. You got 3 different pieces of this function. So this entire thing we call the function f of x. It has 3 pieces. 1, 2, 3 pieces for it. Okay? So what it's... Good night. So what it's going to have you do is says here, find this, find this, find this, this, and this. So right there when it says like f of -5, f of -3, f of 0, and so on, that is telling you what the x's are. And what we're going to do is evaluate and plug these in for the piecewise functions or the inputs formula and figure out what its y coordinate is or what its output is. Again, very wordy here, just bear with me. So now let's start with f of -5. So the x coordinate is -5. So which one do I use? First, second, or third? First, second, or third? I don't know. Well, that has to do with if you look at the inequalities. These inequalities here will actually tell me which one to use. So you use the first one when your x is less than -2. All right, so I am going to use my first one because -5 is less than -2. So I'm going to use x plus 1. I'm going to plug -5 in for x, so -5 plus 1, and that'll give me my output of -4. So your first one is done. F of -5 equals -4. Well, now let's move on to another one. Now we're going to do f of -3. So -3. Look at your first inequality. -3 is less than -2. So I will use x plus 1 again. So x plus 1. I'm going to plug in -3 in for x. -3 plus 1 is -2. All right, now the next one is f of 0. Now here, 0 is not less than -2, so we're not using the x plus 1 this time around. Should we use this one? Well, this, if 0 is here for x, yeah, 0, this is saying for the we're going to use this for the numbers between -2 and 3. And 0 is between those two numbers. So we look and we go, okay, our output here is just going to be 5. So it equals 5. Now there is no x to plug in here. It's literally just 5. There was no x. Nothing to plug in here. All right, next up, f of 3. So 3, should I use this one? Yes, I should, right here. See the underline here? That means 3 is less than or equal to 3. So I am going to use this 5 again as my output. So f of 3 is 5. Okay, next I have f of 4. I'm not going to use my first one because 4 is not less than -2. I'm not going to use my second one because 4 is not in between -2 and 3. Will I use my third one? Yes, I will. 4 is greater than 3. So I will be using this formula. So x squared equals 4 squared is 16. So f of 4 is 16. And then finally the last one, f of 10. All right, which one do I use? Look at your inequalities first. This, or this. Nope. That would be the third one. 10 is greater than 3. Therefore, you should use x squared. So 10 squared equals 100. So you just learned how to evaluate a piecewise function for given values of x. Okay, let's take a look. Sometimes I gotta back up and see what's next. Okay, I'm gonna go down here. And let's try another one, another piecewise independent practice. So we have a piecewise function, f of x. Looks like it has 3 parts, 1, 2, 3. And we have to do 1, 2, 3, 4, 5 problems. So let's start with f of -12. So I look at the inequality and I go, okay, is 12 less than -6? Well, -12. Is -12 less than -6? Yes, it is. So that means I'm going to use this guy here. 1/4 times x minus 5. So I'm going to plug -12 in for x. 1/4 times -12 is -3. And that'll be -8. So f of -12 is -8. Okay, what's next? Next is f of -6. Is -6 less than -6? No, there's no underline there, so no go on that. Would -6 be okay in this for x in this one? Yes, it would. We have the underline here. So that means I am going to use this. So it's going to be 3. Actually, there's no x to plug in. Your answer is literally, your output is literally just 3. Next, f of 1. Okay, 1 is not less than -6. Don't use the first one. 1, would I use that middle one? No, there is no underline here, so don't use that middle one. If it's here for x, 1 is less than or equal to 1. We do have the underline here, so that will work out. So we're going to use the 4x plus 2. So 4 times 1 plus 2. That is 4 plus 2 is 6. Easy stuff. Next up, 0, f of 0. Is 0 less than -6? No. Is 0 between -6 and 1? Yes, it is. So I'm going to use this guy here. The output is literally just 3. No x to put in, so just 3. And then f of 10. So 10, no, that's not less than negative 6. No, 10's not between negative 6 and 1. If I put it in here, yep, 1 is less than 10, so I'm going to use the 4x plus 2. So that's 4 times 10 plus 2 is 40 plus 2 is 42. And guys, I do expect to see all the work, of course. All right, so we did another one for evaluating piecewise functions. Okay, guys, so that's it for my lesson. There is a last thing today. It's graphing piecewise functions. I'm not going to institute it as part of this lesson. I'm also not going to put it into the assignment this time around. I'll just save it for a separate day for like an Edpuzzle or something. So that's it for the lesson, guys. Just get your work done and follow through with the assignment. Have a good day.